Okay, so let's do some examples, right? Let's do some that are a little bit more complicated. What we're going to do in these examples, though, is we're going to forgo the restrictions because what we really want to concentrate on is the algebra behind it. So let's make sure that we can do that first. So let's go ahead and look at this problem, right? Well, what I want to do is I'm going to split it into two parts, right? The numerator and then the denominator. So the numerator is just that one. And the LCD of these two things, they have two different denominators here. So the LCD is just the product of the two. So what I'm missing in the first one is going to be x minus 3. And then what I'm missing in the second one is going to be the x plus 3. So once you have all that written out, we can add the top or subtract the top and keep the bottom. So this entire thing ends up being x minus 3 squared minus x plus 3 squared, all divided by 1 of each, the product of each. So this one step, right, this entire section right here, that's just the numerator. So we still have to go and do the denominator. The denominator is going to be the exact same thing. So I don't know if you can see it right off the bat, but the LCD is the same, right? It's x plus 3, x minus 3. And then we're going to have, instead of a subtraction, in the middle, we're going to have an addition. So does everyone see that they're exactly the same just by changing that? So I'm not going to do all of that work because I already know what the answer is. It's this with a plus in the middle. Once we have the numerator and the denominator, we're going to take the original equation, right, flip the bottom, and then multiply to the top. So I'm going to erase this one part. So we have that whole thing, and yes, it does look a little nasty. And it's going to be all divided by the denominator, which is x minus 3 squared, plus x plus 3 squared, divided by x minus 3 times x plus 3. Now that I have that written out, I'll go ahead and erase all of this. Okay. So flip the bottom. And then multiply it to the top, which is going to be x minus 3 squared minus x plus 3 squared, all divided by x minus 3, x plus 3. So right now, this and this all cancel. The one thing that you cannot do is cancel the x minus 3 squared plus x plus 3 squared with the other side because there's a subtraction in the middle. So the only time we can do cancellation when there's a division is if it's multiplication. So we have to actually evaluate all of this. So x minus 3 squared, x plus 3 squared, divided by x minus 3 squared plus x plus 3 squared. So let's go ahead and write out the expansion. X squared minus 6x plus 9 minus x squared plus 6x plus 9. And again, because these are the same, but with the signs in the middle just being different, all I need to do is change the sign and copy. and I'll go ahead and color it. So this part over here is that part, which is also the same as that one. This part over here are those two parts. So that is why I'm able to change this sign in the middle. So go ahead and simplify it. The negative x cancels. So this one and this one cancel. The 9 and the minus 9 cancel. And so the numerator is left with minus 12x. The bottom part, the x's cancel. And I'm left with, on the bottom, 2x squared plus 18. And don't forget, you can't just stop there, right? You gotta see if there's anything that can be canceled out. And you can actually factor out from the denominator a 2. So I'll rewrite it here, which is going to give you 12x over 2 times x squared plus 9. So this and this can simplify as 6x over x squared plus 9. So we don't have anything that can factor from the bottom because it's a plus, it's not a difference of squares, so you leave it as that. So this is going to be your final answer for the simplified version. So really complicated problem, right, if we have to find all those restrictions on the function itself. So that's why we really want to concentrate on the algebra. This next problem is a little bit different in the sense that we first have to notice that it is actually a complicated rational expression. And what it is doing, right, it has these negative exponents. And the negative exponents, remember, can be written as 1 over. So convert this first as 1 over m squared, because m to the minus 2, in order to get rid of that negative exponent, is 1 over whatever was left. Similarly, the negative 1 is attached just to the m, so you get 1 over m. And on the bottom, you get 4 1 over m squared. If you want, the 4 and the 2 can go on the top because it's multiplication of fractions, and multiplication goes straight across, like that. Now again, it goes back to a problem that we had before where we find the LCD. So what I'm going to do in this problem is I'm going to find the LCD of the whole thing instead of doing it as the top and the bottom. So what I'm going to do is I'm going to get all the denominators and find the LCD of all of them. So the LCD, remember I'm looking for m. There's nothing different in any of them except for a 1 there. And the highest exponent of all the denominators with that variable is going to be the square. So really the LCD here is nothing but m squared. So what you can do with this is I can multiply the entire top and the bottom by the m squared. So what I'm going to do is I'm going to rewrite this by multiplying the top and the bottom by m squared. Use the distribution, so you get m squared divided by m squared plus m squared over m divided by n cubed plus 4m squared over m squared. Now, what I did was I took this and multiplied to that. But if you multiply fractions, you multiply straight across. So 1 over m squared times m squared is m squared over m squared. And that's this one part. And hopefully you can do the rest, right? The m squared multiplied by the 2m just means that there's a 2 here. The m squared goes onto the top with that 2. The m and the m squared, when you multiply the exponents, they add together, so 2 plus 1 is 3. Now, notice, right, when you have this property, right, all these m squareds, they don't disappear. So what you're left with is 1 plus 2m divided by m cubed plus 4. So all the denominators disappear from the complicated part of the fractions. So now what you need to do is just try to simplify this single fraction. But there's nothing we can do because we don't know how to factor this bottom, and the top has no factors either. So there's nothing that we can do to simplify. And that would be your answer.